So, for any problem where we are dealing with exponential growth, you'll hear of a term called doubling, tripling, quadrupling, or something like that. Now, in order to apply this using this basic equation, we're going to use this equation, y equals ab to the x. Now, let's write that down. So we're going to use this, y is equal to a b raised to the x. We called this exponential growth. Sometimes we call this appreciation. Now, sometimes you're going to get questions that are presented as follows. This is a table question where you have to do some analysis and then you're going to have to create an equation. So, Mr. Simpson puts 1 nickel, 5 cents down on 1 square of a chessboard. He then proceeds to put 10 cents on the next square, then 20 cents on the next. Now the question is, how much will he have by the 20th square? These problems tend to require you to do some analysis, and some of that analysis will be in the form of a table. So you'll notice that I have a table here, and you'll notice that I have values from x equals 0 all the way up to 5. So now this will allow me to go and actually type the values in. So you could use Desmos or whatever you want to get this thing to work. So now, if I start with 0, we start on the first square, which is our starting value. We end up with 5. On the second square, we end up with 10. And then 20. And then 40. And then 40 times 2 is 80. And then 80 times 2 is 160. So these are the number of cents. So recall from before, we also talked about the idea of first ratios. When we were dealing with these types of equations, these exponential functions, we're dealing with stuff that is either doubling, tripling, or whatever. And as you can see, as we move up here, each time, the numbers are just a multiple of the previous. Now, in order to show that mathematically, we basically go, okay, what is 10 divided by 5? Isn't that 2? And the same could be for 20 over 10. Isn't that also 2? And we do that for 40 and so on. We end up with 2 and 2 and 2. And we call this the first ratio. Now, the only time that you have first ratios being the same is when the equation is exponential, because the first ratios are the same. So now that we have identified that this is an exponential function, we have to choose one of these two equations that we started with up here. Anytime we're doing an analysis using a table like this, and we find out that our information is doubling, i.e. the ratio is 2, we will always start with this equation. Y is equal to ab to the x. Now, remember that first ratio that we calculated earlier. The b value, you just have to write, since the first ratio is 2, therefore b equals 2. You could have also said this, or you could have also said this, since the amount doubles all the time, b is equal to 2 in our equation. Now, the last part of this problem, so b represents the amount that we're always increasing by each time, the multiple that our information is growing by. So that means we need to find this a value, okay? Because we'll be able to vary y and x, and that's all we need to find, just is the a value. Now, the A value represents the starting value. So I'm actually going to write this in red. A is the start value. And then remember, B is the ratio. So in this case, the starting value for our problem starts as the first problem where x is equal to 0, and in which case our starting value is 5. So our starting value is 5. Start value that means A is equal to 5. So our equation, when we rewrite it, is just going to be this. Y is equal to 5, 2 to the x, where 5 represents the 5 cents we start with. So now, if I asked you to answer that question, when we want to find where our function is, where we have the 20th square, for the 20th square, therefore, for the 20th square, all we're going to do is replace x with 20. So we write y is equal to 5, 2 to the 20, and we get some number. Now you got to remember that what that x represents is the 20th square. So we end up with y is equal to 5 times 2 to the whatever, which gives us 5,242,880 cents. For the next type of problem you'll see problems that look similar to interest being tacked on yearly. We call that percent increases, and that is what we're doing here. In that type of equation, we're end up going to be using this. Y is equal to A, 1 plus R to the X. And we call this, remember, we'll call this an appreciation. And we'll still call this growth as well. The next type of problem that we're going to deal with is a money growth problem or biological growth problem. So let's say that we don't know that it's doubling or tripling, but we do know that we have a certain percent increase every year. I'm going to call this the money or growth problem. Now, when we do this problem, you're going to see something that looks like this. So years ago, I've basically invested $5,000 into an RRSP. And now that RRSP gave me about 2% interest every year since the year 1990. Now, how much money do I have in 2017? In order to do this problem, you're going to have to tell me what X is, and you're going to have to tell me what Y is, right? X is just going to represent the year since 1990, and we're going to let Y represent the amount of money that I get. Now, before we used to do an analysis, so if it was a small enough number, we could actually find the amount that we needed in 2017. Now, you just got to remember that the 0 in the X column represents 1990, the first year, which would be 1991, which would be number 1, and then 2, and then 3, and then so on. So, in order to do the rest of this problem, we're literally going to have to figure out what X is. Now, X originally starts at 1990. So in order to find our X value, we're going to have to go and take 2017 and subtract 1990 from it. Now, doing so, you end up with approximately 27 years. So now, when we write our equation, our basic equation is this. Y is equal to, well, our start value we said was 5,000, right? Because that's how much we started with at the very beginning of our investment. And then we write 1 plus, using the equation that we have up here, 0.02, raised to the x. Now, you just have to remember that anytime we're dealing with percentages, with rates, we have to take whatever the percentage is and turn it into a decimal. If we are increasing, growing, we go 1 plus that percentage as our b value that we had in this original equation. So essentially, for each one of these numbers here, we're essentially multiplying each of these numbers by 1.02 all the way down. And by doing so, you could have, if you wanted to, calculated the 15th year, which would have been ridiculous. Sorry, the 27th year, which would have been ridiculous. So you could have done that, but instead we calculated that x was supposed to be 27 in our calculation. So let's do that. So now I get y is equal to 5,000 times 1.02 raised to the 27. Now that represents the 27th year of my money being in that RRSP. So calculate, you get your final answer. With rounding, we get the following. Y is equal to, well, $8,534.34. So Mr. Simpson has $8,534.34 by 2017. And we're done.